All right, guys, number 6 was another pretty tough one right here. Let's take a look at what's going on. They've given you an explicit definition for g of x here, 4 times x plus 1 to the negative 2/3, and an explicit definition for f of x written as an integral of g of t. Gotcha. And we're supposed to find f of 26. Well, when they give you the explicit definition, let's use it. So f of 26 then will equal, just following this right here, the definite integral from 0 to 26 of g of t. That would be given to us by this function right here, 4 times, really that should be a t, but it doesn't really matter, whichever variable you want to use. Most of you prefer an x, so x plus 1 to the negative 2/3 power, all taken with respect to x. So what are we going to do here, guys? I would pull that 4 out in front right here, gotcha, although it doesn't really matter here. We're going to keep the base the same, x plus 1. We're going to raise this exponent by 1. Negative 2/3 plus 1 is 1/3, and we're going to divide by that new exponent. Dividing by 1/3 is the same as multiplying by 3. Technically here, we would now need to divide by the derivative within the base of that exponent, but the derivative of x plus 1 is 1. We can get away with ignoring that. So that's going to be our antiderivative now, evaluated from 0 to 26. So the 4 times 3 is going to make a 12 out in front, and now I'll go ahead and start a set of brackets. 26 plus 1, okay, now I get it. 26 was a weird number, but when you add 1 to it, it becomes 27, which is special because it's a perfect cube. And the cube root of 27, that of course is what the 1/3 power means, is 3. Minus, all right, 0 plus 1 gives us 1, which is also a perfect cube. And the cube root of 1 is 1. So we end up here with 12 times 2, and we're going to get 24 here for the value of f of 26. And that's what's going on in part A. How about B? Determine the concavity of the graph of y equals f of x for x values greater than 0, and these wonderful 3 words here justify your answer. All right, guys, anytime we come up with concavity, that should tell us that we need to deal with and analyze our second derivative. So first we need our first derivative here, f prime of x. Now, actually, you know what? I probably should have moved this down a little bit. One more time here. It told us from the previous slide here, guys, that f of x, hang on, I got it right here, is equal to the definite integral from 0 to x of g of t dt. That means our first derivative, f prime, is the derivative of this integral expression. Well, this is set up perfectly for fundamental theorem part 2. A definite integral with a constant on the bottom and an x on the top just becomes g of x. Okay, the derivative and the integral cancel each other out. And then f double prime of x would just be the derivative of the right side, which is g prime of x. All right, so if we have that, all right, we're making some progress right now, but now we better find g prime of x. And let me write down again, just in case you forgot it, that g of x was 4 times x plus 1 to the negative 2/3 power. So the derivative of that, this is kind of messy. The negative 2/3 gets multiplied by 4 to make a negative 8/3 out in front. That gets multiplied by an x plus 1, same base. We drop the exponent by 1 to make negative 5/3, and then multiply by the derivative within, which is yet again equal to 1, so we can ignore that. So we get this ugly second derivative here, guys, of, I guess the best way to write this is negative 8 over 3, and then x plus 1 to the positive 5/3 power. That's not real pretty, but okay, that's where we're at. And now, for us to answer the question right here, we have to determine the sign of this second derivative here for all values of x that are greater than 0. So let's think about that. Anything greater than 0 that you put in here is going to make this base a positive number. And a positive number to the 5, really to any power, to the 5/3 power, will be positive. Multiplied by 3, still positive. But then negative 8 divided by our always positive denominator is going to get us an answer here, guys, that is always, always, always less than 0. This second derivative is always going to be negative regardless of what x value you put in there. And that tells us this curve is going to be concave down. So let's answer the question, guys. F is concave down, gotcha, for all x greater than 0 because, and now I just need to tell them what I've deduced right here, because f double prime of x, which is equal to, you don't really need to write this because I already have it here on the paper, 3 times x plus 1 to the 5/3, because that second derivative is less than 0, again, for all x. Really, it's greater than -1, but we'll just leave it as all x greater than 0, and that's my answer, and a pretty darn good justification there for part B. Okay, so we got that one down. Now the third part right here, let h be a function defined this way. H is x minus f of x. And we're supposed to find a minimum value of h on an interval from 0 to 26. Okay, guys, basic stuff we ought to know. Where can you find a minimum value, or where can a minimum value occur? Either at endpoints or at critical points. So the endpoints are right here in 0 and 26, but we need critical points. Critical points come from your first derivative. H prime of x then, the derivative of this expression right here, well, the derivative of x is 1, and the derivative of f is going to be f prime of x. That's h prime. But wait a minute, just on the last page we wrote down something interesting right here, that f prime of x is equal to g of x. So that means I could write this as 1 minus g of x. And we want this derivative now to find a critical point here, guys. We want this derivative to equal 0. So I'll do the same thing right here, and now I'll work on solving this equation. I'm going to bring that g of x to the other side and get 1 has to equal g of x. And g of x, we had an explicit definition for. I guess I had it right there. So it's that ugly expression right there of 4 times x plus 1 to the -2/3 power. That's g of x, and we want that to equal 1. And obviously, since this is a non-calculator question, they expect us to be able to solve that by hand. I'm going to divide both sides by 4 and get x plus 1 to the -2/3 power is equal to, that'll be a 1/4. And here's a little trick here, guys. I don't like solving an equation with a negative exponent, so I'll do this in 2 steps. If you were slick, you could do it in 1. I'm going to take both sides here to the -1st power. Now, what's that going to do for me? Power of a power is when you multiply your exponents together. So this left side is now x plus 1 to the +2/3 power. That's easier to deal with. And on the right side, the reciprocal of 1/4, that's really what a -1st power is telling you to do, the reciprocal of 1/4 is 4. Now, the second thing we're going to do to get rid of that 2/3 power is take both sides to the 3/2 power. So the 3/2 gets multiplied by the 2/3 to make 1 for your new exponent, which of course you don't have to write. So let me move up here, guys. That's now going to give us x plus 1 is equal to, and oh man, we have struggled with this throughout the year, guys, 4 to the 3/2 power. What that means is the square root of 4, and then you should really do the square root first and then cube that result. Square root of 4 is 2. 2 cubed is 8. So where was I? Back to purple here, guys. So that right side, 4 to the 3/2 power, is going to become 8, and we're going to subtract 1 from both sides and get x equals 7. And holy cow, guys, all we have done up until now is found your one and only critical point. So we have a critical point here, and we have 2 endpoints right over here. Might want to label those as well. That means that there are 3 x values at which we're going to have to test out the value of this function to find out which one of them gives us the minimum value. So we still have a lot of work ahead of us here on this problem. We're trying to find a minimum value of h. So give me just a second here, guys. Let me shrink that page down a little bit. We need to test h at all 3 of these values. We're going to need to know the value of h of 0 followed by h at our one critical point, which is 7. And I think the last one here, guys, was h of 26. Let me double check that. Yeah, that's what was going on here. And then I should write this over here too. The definition of h of x was x minus f of x. I'm just rewriting this right here. So when I scroll down, I'll still be able to see that here. All right, guys, let's get started. H of 0 starts off with your x coordinate, which is 0 minus f of 0. Well, f of 0, have we answered that question yet? Well, I don't really think that we have, but if we go back to the original expression or the definition right here, f of x is an integral from 0 to x. Well, if that top x is 0, this is an integral from 0 to 0, which is guaranteed then to equal 0. So this becomes 0 minus 0, and we end up with 0 then for the value of h of 0. Oh, would that every other problem here was going to be that easy, but that's that one. Now life gets tougher. H of 7 is going to be a 7 minus f of 7. And correct me if I'm wrong here, guys, or pardon me if I am, I don't think we have found the value of f of 7 yet in this problem anywhere. Ooh, we do know the value of f of 26. That's 24. That's going to come in handy on the third point that I need to check. But for now, we need to figure out what f of 7 is, and I might as well do that right here because here is where I have that definition. It is the integral from 0 to 7 of g of t right here. So this function here, 4 times x plus 1 to the negative 2/3. Well, taken with respect to x. This is going to follow a lot of the same work that we did just a second ago. Not much changes here, guys. You still get the 4 times 3, which is a 12 out in front. It's still times x plus 1. The power is still now 1/3, but now we're putting in values of 0 and 7. So what do we get here? 12 times, okay, and now I get yet another joke. 7 added to 1 gets you 8, which is yet another perfect cube. So the cube root of 8 is 2. Minus, putting in the 0 here, got us the cube root of 1, which is 1. And we end up with 12 times 1, which is 12. So f of 7 is 12. Back to where we were just a moment ago then, guys. Let's scroll up. Come on now. On this page. Come on, there you go. So this is going to be 7 minus, and we just came up with f of 12. I'm sorry, f of 7 equaling, well, shoot, did I have that right now? F of 7 was equal to 12. There we go. And 7 minus 12 is negative 5 for the value of h of 7. And lastly, h of 26, again, it's going to be x minus f of x. So 26 minus f of 26, which is going to be 26 minus, and as we said just a moment ago right here, sorry, I didn't have that there, f of 26 was equal to 24. So at least I got to duplicate a little bit of work right there. And 26 minus 24 is 2. So at this point, everybody, these three values are your potential candidates for your, hang on, we were looking for a minimum value right here. So the lowest of those three then looks like it's going to be negative 5. So this right here is going to be the minimum value, and that is good enough for my answer. They didn't ask for a verbal explanation or anything like that. I've shown them a lot of work, and I think I've pretty clearly communicated what it was that I was looking for there. So I feel good about this answer right here for part C. Okay, guys, so that's all of number 6, all wrapped up into one.